Okay, here's video number 2 for section 8.1.2, more graphing of polynomials. I know this is a lot of notes for you guys today, but just bear with me. This is all really important stuff that really was building up all week. It's stuff that I want you to have good notes on for studying for your test that's coming up. You have a quiz on Thursday of next week, and all this stuff is good stuff for you to be taking notes on. Okay, so we're going to skip around a little bit at the end of this section, just skipping a few problems. We're going to start with 8-29, and it's going back to a graph we talked about in the previous video. And when we look at this, you guys should remember that because on the right side it's going down, that means it's going to be a negative orientation. And because it goes up once, down twice, it has to be at least an x squared. Okay, so let's talk about a little bit what that means, that it's at least an x squared. If I have these two equations, let's see, x minus 1 squared, y equals x minus 1 squared, and y equals x minus 1 to the 4th. If you graphed these on your graphing calculator, they would both basically look like this. Okay, they would both have an x-intercept at 1, and they would both bounce off the x-axis at 1. The difference is this is for sure a parabola, and this one would be a more flat and then steep. Flat and then steep. Now that's just a really rough sketch, okay? But when we say that you see this thing and it has to have at least a degree of 2, it means it could have a degree of 2, of 4, 6, 8, 10, any even number at this for this graph. It couldn't possibly be an odd graph, because think about x to the 3rd would not only go up down, it would have to turn one more time. Okay, so there's no possible way that this graph could be odd. It has to be even. The tails are pointing in the same direction, so whether they're both going up or both going down, it means it has to be an even degreed graph. Okay, in the same respect, still talking about number 29 here, if we think about this graph, we think of this, again, a lot as x cubed. Because the top is going up, we know it's a positive x cubed graph. It has to be at least x cubed. It could be x to the 5th. It could be x to the 7th, x to the 9th, etc. It has to be an odd degree because the tails are going in opposite directions. And again, if you wanted to look into this further, think about, or go to Desmos and graph, or use your graphing calculator. Graph x minus 1 quantity cubed, and graph x minus 1 quantity, to the 7th power. And if you graph these two things, again, we know it's going to cross at positive 1. It's going to do a lounge. Okay, that's what I'm calling a lounge. When it kind of flattens out, it looks like the cubic. This one is going to look the same, so you go to the right one. It's just going to be a lot flatter and then really, really steep. Flatter and then really, really steep. So these two essentially are going to look the same. If you really analyze them together on the same graph, they're not going to be exactly the same. They don't have the same ordered pairs, but their shapes are the same. Their behavior is the same. It's just that this one is a little bit flatter. Okay? So the next one I want to talk about really goes right in line with what we just said, is, well, what if we have in an equation we have something squared with another factor, or something cubed with another factor? So remember, this is a positive orientation, so we know on the right side it has to go upwards. We know that it's going to cross the x-axis twice, or have two x-intercepts. One's going to be at positive 2, one's going to be at negative 5. But at negative 5, it's going to be a bounce. Positive 2, it's going to go right on through. There's 1x. There's 2 x's. X times x squared. This is going to be an x cubed graph. Not a minimum of x cubed. If we multiplied it out, it's just an x cubed. Okay? Ending going up. So if I go backwards, I needle and thread down. But remember, at the 5, I'm bouncing at the negative 5, so I come up and touch it and go back down. Okay? When there's a squared, 4th, 6th, 8th, anything even, it's going to be a bounce. If it's 4, 6, 8, it's just going to be a little flatter bounce. Okay? And I'm not going to be super worried if you're graphing x something squared compared to something to the 4th. I'm not going to really analyze, did you flatten it out? Okay? I just want you to show me that it's a bounce. This graph, okay, is positive again, so on the far right side it's going to go up. It's x times x cubed, so this is going to be an x to the fourth graph. So let's see what this looks like. It's the same x-intercepts as this one. We're still at -5 and +2, and we're still going up from +2. What's happening here when it's cubed, it's a lounge. So I'm going to drop down. I have to turn around and come back up. But when I come back up, I'm going to make sure I do it in like a lounge fashion. So I'm going to come back up, kind of like a cubic. And that takes some practice before that looks good. The first couple times you do it, it probably is going to look a little goofy, and that's okay. All right. Next, again, we're still talking about all the same stuff. 8-32 is talking about even and odd degrees. Even degrees are things that have the tails that start and end in the same direction. Okay, maybe it's down, but whatever it does, it's got to start and end the same for an even degree. If it's an odd degree, it's going to start and end opposite. Think about your basic line, y equals x. Those tails go in opposite directions. To the left, it's going down forever. To the right, it's going up forever. Same thing with a cubic. Of course, we might have a -1, okay? But the point is, if it's an odd degree, the tails are going in opposite direction. If it's an even degree, the tails are going in the same direction. Okay. Finally, number 35, this is the last thing you need to do in your notes today. You need to write down these 3 equations on your paper. You need to sketch for me. Remember, that means on the x-axis, I need to see what are the x-intercepts. Are there bounces? Are there lounges? I don't care anything about numbers on the y-axis, okay?